Okay, question 40. Kira's on her bike ride, obviously getting her exercise for today. Let's see how long it takes her. Okay, so off she sets, and on the first section of the journey, the acceleration is a function of time here. So that tells us that we can't use SUVAT because the acceleration is varying. So to find the velocity, we have to integrate acceleration here. And when we integrate acceleration, we get 1.6t, and then add 1 to the power, divide by the new power, 0.08t squared, not forgetting the constant of integration. But we're told that she starts from rest, so that means that when t is 0, v is 0, so that tells us that this c on the end here is 0. So we now get an expression for v. So how do we get an expression for displacement? Well, similarly, to get from displacement to velocity, from velocity to displacement, we integrate. So here's our expression for velocity. We add 1 to the power and divide by the new power, and we get this expression, which has got our constant of integration. Again, when t is 0, s is 0 because she's starting from what we're taking to be the origin. So that tells us that s is 0.8t squared minus 0.08 over 3t cubed. Using that, we can find out how far she travels in the first 10 seconds. So the middle section, the 30 minutes in the middle, there's no acceleration at all. It's constant speed. So we can just use distance equals speed times time here. We know what the time is, it's 30 minutes, but what's the speed? Well, her speed at during this period of the cycle will be at the same as the speed that she finished accelerating at when t is 10. So when we put t equals 10 into our expression for velocity, we get v is 1.8, and so the distance that she travels on that middle section is 8 meters per second times 30 minutes times 60 seconds, which gives us a total of 14,400 meters. So now we move on to the third section of motion. So in this section, we're told that we've got a constant constant deceleration of 0.5 meters per second. So we can use our old friends, the SUVAT equations, the constant acceleration formulae. And when we do that, the values that we use are u is 8, the initial velocity, v is 0 because she's coming to rest, and the acceleration is minus 0.5 because she's decelerating. So to find the displacement during this final section, I'm using the formula v squared equals u squared plus 2as. When I plug the values in, I get s equals 64. And when I use v equals u plus at, I get t equals 16 seconds. So when I add the 3 times together, I get 30 minutes 26 seconds and the total distance of 14,517 meters. A little bit perhaps over accurate that. We might actually write down the final answer as 14,520 perhaps. Anyhow, that's the answer to the question. Let's just double check. Find her total journey time and total distance traveled. Yes, we've done that by adding the 3 different parts of the motion together. Hopefully you got the same answer as I did. If you did, well done.